Going into section 6 of chapter 5, this is where all of what we've done this term is coming to closure. All of the skill we did with identifying terms and coefficients and the various operations we do in algebra, solving equations, multiplying, because now we are going to factor trinomials in the form of x squared plus bx plus c. And if you remember, this is the standard form of the quadratic expression. Now, we saw earlier that if we took a binomial factor and multiplied it by a binomial factor, eventually we would end up with a trinomial. And if we went this way, we ought to be able to go back and factor it, this trinomial, into its binomial factors. This is what we are assuming for this section. So let's look at a particular example and then figure out what are the steps. Now, of course, you can read the textbook, and that goes over it in some detail as well. But I never wanted to particularly read the textbook going over the textbook. I wanted to comment on it, and that's what we'll be doing. So let's take a look at our first example. X squared plus 10x plus 16. Now, as we look at that, is there any common factor in there? No. So what we're going to do, because we're thinking it might factor into two binomial factors. So in your homework log and wherever you do these, you're going to write your trinomial, factor out any common factor, there is none here, and then put two parentheses under it. Then you look at your first term, because what we're going to do is undo the FOIL. Now, to get this first term, we had to multiply something here and something here and get x squared. Well, that's obvious, going to be an x and an x. Now we're going to fiddle with the rest of it. We know we had to multiply this term by this term to get our last term. And then when we did the outers and the inners, it had to add up to what we have for a middle term. So we start listing the factors. 1 and 16, 4 and 4, 2 and 8. You might say, well, wait a minute. 2 and 8 adds up to 10. And when we multiply it, makes a 16. So this is what we're going to put there. Now we have to figure the signs. Well, since they're all positive, this is the easiest one. All of these then just become positive. And we check it. Now let's do this one. Now I'm not putting it underneath it, so we have room here. So an x and an x. Now factors of 6 that add up to 5. Well, 2 times 3. And what do we always do when we get to this stage? We FOIL it to be sure we get our trinomial. And these check out. So as we look at example 2, is there a greatest common factor that we can factor out? No. And it's in standard form, so we put 2 sets of parentheses. Now again, we're undoing the FOIL. What are we going to put in our first position? Well, that's easy. X and x. Now we're looking for factors of 35 that are going to add up to a 12, a negative 12. We'll get to that shortly. Well, we go through all the factors and we end up with a 5 and a 7. 5 times 7 is 35, and if we add our outers and inners, add up to 12. Now, in order for it to add up to a negative 12, both of these now need to be negative. And when we multiply our last, we end up with a positive 35. So this checks out. Now notice they wrote it a little differently here in our textbook. Perfectly fine. Looking at example 3, is there a greatest common factor? Yes, we could factor out of every term 5x. And now we get x squared minus 6x minus 7. So now we write our 5x and then put 2 sets of parentheses. So once again, our first term is easy. Now notice the array of signs now. We have a negative here and a negative here. In order for that to happen, one of these need to be positive and one of these need to be negative to end up with a negative. But for our middle term, we have a negative 6. So what are the possible combination of factors of 7 that will give us a 6? Keeping in mind one's positive and one is negative. Well, if our 7 is or our negative is a 7 and our positive is a 1, notice now our outers are a negative 7, our inners a positive 1 adds up to a negative 6, and then when we FOIL our last, we get a negative 7. So this is the factorization, and in your work, as you write these out, we should see that you've factored out this. It's almost impossible to go from this step to this step. You have to factor that common factor out first. In example 4, it's written in standard form. We could see we could factor out a 2 from each term. So this is n squared minus 19n plus 40. Now again, we put our parentheses, and since n is just a 1n, it's easy to do our first terms, an n and an n. But now what we have to do is figure out what are the factors of 40 that are going to give me a negative 19. Now, they have it laid out nicely. It'd have to be both negative. So this is going to add up to a negative 41. This adds up to a negative 22. This adds up to a negative 14. And this adds up to a negative 13. And you might say, we don't have any that would add up to a negative 19. So in a case like this, the most you can factor there was this, and it doesn't factor beyond that. Now, a little bit of what we'll be doing throughout these next few lessons is guess and check, or trial and error. That is, you try something, you guess something, you check it, and you see you're right or you have an error. And then you go back, and once you are completed, and in some of these cases there's not going to be any factor that you can take out, and those would be considered prime. and that would be the answer, prime. But here we could take out a 2. Now, so far we've been factoring things where the value in front of our first term, the second power of something, was a 1. But now, how about if that 1 isn't a 1 anymore? So we then get to a new standard form where a up here was 1, but now we're saying a does not equal 1. How do we do those? Well, this takes us to our second objective, factoring this form of trinomials. And again, here we're particularly going to use this trial and error, guess and check. But I see here they're saying trial and check. I had left that one out. So let's take a look at our first one here. So as we look at it, there is no common factor. It's in standard form. So we put, as part of our protocol, 2 parentheses, and let me get rid of this right there. Now again, we're going to try to undo the FOIL. So to get our first term, which is a 2x squared, since 2 is prime, there's only the one possibility, 2x times x. Now here we have a 15. So we could put a 3 there and a 5 there. Now doing so, our outers would be 10. Our inners would be 3. That would add up to 13. So that's not going to work. So again, trial and error, trial and check. How about putting the 5 there and the 3 there? Now when we do our outers, we get a 6x. Our inners of 5x, that adds up to 11. And since everything is positive, that's not a challenge at this stage. And again, FOIL this, and we get that. Now, the textbook goes through a lot of detail as to how you are guessing and checking, trialing and erroring. Yes. And what I did in the last example was summarized here. And again, there are combinations where there are no combinations, and we consider it prime. So let's do example 6. So we have 3x squared minus x minus 4. Again, it's in standard form. No common factors to be factored out. We put 2 sets of parentheses. Now, since our a term here is prime, that's our easy first term here. X, 3x, and x. Now, what do we have as possible factors of 4? Well, we have a 1 and a 4, a 2 and a 2, and then a 4 and a 1. So it's just a matter of trying these there, some of which you can do mentally. So if we put a 4 there and a 1 there, that's not ever going to be a negative 1. If we put a 2 there and a 2 there, nope, that's not going to work either. But how about if we put a 4 there and a 1 there? Because if we do our outers now, that's going to be a 3x, and our inners are a 4x, and the difference between them is 1. So we want our middle term to be negative, so we put a negative there. That'll make it a negative 4x. a positive there, that's a positive 4x. And then when we FOIL for our last term, we get this. Ah, we have done it. Now again, I'm outlining a procedure that through guess and check, you're going to develop your skills or rekindle the flame of your high school skills. Now here they're going over some helpful hints. The sign pattern. If they're both positive, these are both going to be positive. If the first and last are positive, but the middle one is negative, then both of these must be negative to get this positive. Now, in a case like this, where their second and third term are negative, we know that one of these need to be positive and one negative. And then it's the combination of your outers or inners that give you the largest factor of that sign. That is, in this case, negative. It'll be a combination of the 2x and the 3 to give you a negative. And then one's positive, one negative, so your third term is negative. And then here, if this is negative, the third term, but this is positive, your middle term is positive, then the combination of the outers, which is the largest combination to give you a 6, needs to be positive. So again, this is a little trend that you might pick up just doing a lot of them, but here it's summarized. Okay, let's do example 7. Looking at this, we see I could take a 2 out of each one of these. I couldn't take a 4 out of there, so I could take a 4 out of there and there, but not there. So the largest common denominator that I can factor out is 2. Then I have x to the third, x to the second, x. So I could factor out an x. And then each of these terms has a y. So I get that. So I now get 12 x, no, let's, got carried away there. So this is a 6 x squared minus 11x plus 4. Okay, and that's what they have there. Of course, I could look there and just copy things, but I'm trying to work it out as if I were a student here. Okay, so we write the 2xy, and now we're going to put 2 sets of parentheses. Now, since we have a 6x squared there, 6 is not prime. I could have here a 6x and an x, and a 2 and a 2, and again I'm going to have to fiddle with this. So let's try the 6x and the x. Now I know I can't put a 4 there and a 1 there. That would be too big. 24 something or other, 23. All right, how about, or 25, how about a 2 and a 2? Well, this would be a 12 and a 14. No, that's not going to work. So I thought about the 6, and I didn't do it that carefully. I'm just brainstorming here. Now, what other factors of 6 could I use? Well, I could use a 3 and a 2. I didn't leave much room there. Okay. Now, again, I'm going to go a 4 and a 1. No, it's not going to give me 11. Now, if I put the 4 there and the 1 there, no. But let's try the 2 and the 2. Now, here I get a 6 and a 4. That one's not. So that's not going to work either. So I didn't try, or I did, but I didn't look at it that carefully. Let's try a 4 there and a 1 there. Ah, now I have a 3x and an 8x. This adds up to 11, and if they're both negative, that's a negative 11. And then when I multiply my last, I get a positive 4. So this one was a little more challenging. And again, when your A term is 6, that leads to that. Okay. Now we're going to do a lot of practice in our mini lecture program, so we will continue here. If a trinomial has no common factor other than 1, then none of its binomial factors will contain a common factor other than 1. Okay, so let's do example 8. So we have 16x squared plus 24xy plus 9y squared. Now, one of the things we mentioned earlier when we were foiling and doing special products is a perfect square trinomial. And if we recognize that, our first term is a perfect square, our last term is a perfect square, and if we take the square root of 16 and get 4, and if we take the square root of 9 and get 3, and we multiply 3 times 4, get 12 and double it, and get this, 24, this is a perfect square trinomial. And part of it is recognizing it. And we write that in this way. So this is going to be 4x, and this is going to be 3y, and we're going to use the sign of the middle term, plus. So let's see if this expands into this. Square the first term, 16x squared. Multiply these two together, 12xy, double it. Square the last term, and we have it. So that's what this is. Now, theoretically, you could have written it this way as well, but this is the preferred way. And they are mentioning this as the perfect square trinomial. Now, our book mentions another method of factoring, which is called often the AC method, that we're going to illustrate now as method 2, another method for factoring. Now, we did mention this as the AC method in some books, that's how it's called, where we take our A term and multiply it by our C term. This is A term, this is the C term. Now, multiplying the 6 by the 6, we get 36. Now, we're looking for factors of 36 that will add up to our B term, which is 13. So we try different ones out. 1 times 36? No. 2 times 18? No. How about 4 times 9? Ah, that adds up to 13. So now what I do is I rewrite my trinomial into a 4-term polynomial. 6x squared plus 4x, take this one, plus 9x plus 6. Now notice this trinomial and this 4-term polynomial are exactly the same, except we combine like terms there. But now by putting it into a 4-term polynomial, I could factor that by grouping, which is another term this method goes under. So let's factor out here 2x, and then I get a 3x plus 2 there from these first two terms, and then I'm going to factor out a 3 from this, and I get a 3x plus 2. Oh. So again, it's just another way of looking at a trinomial that came from a polynomial where we combined our middle-like terms, but getting this now allows us to factor by grouping, which is a little easier than perhaps trial and error that we used before. So this then becomes 2x plus 3, and our common other factor, 2x, 3x I should say, plus 2. Okay, had to save myself there. And if you FOIL this, you would get this. But if you did this the other way, multiplying this times this, and then this times this, you got that step, got this step, and then combined like terms. So another way of doing it. This is called the AC method, or factoring a trinomial by grouping. But you had to figure out what were the factors of A times C to give you that middle term, and then rewriting it as a 4-term polynomial. We'll do example 10 on the next page. So we want to write it. We have identified our A and C term, and now we get a negative 36. Now we want to know factors of a negative 36 that are going to add up to a 9. Well, we try the different factors out, and we get, let's say, 3 times 12. Our 12 needs to be negative, and our 3 positive. Now we're going to rewrite our B term, x 18x squared, plus, let's do minus 12x plus 3x minus 2. That's better. Now, I was thinking of putting the 2 there, but this way's better. And again, you have to think about it. So out of here, I'm going to factor out a 6x. And I get 3x minus 2. Now, lo and behold, what do I have here? 3x minus 2. But what did we say we can always factor out of anything? A positive 1. 3x minus 2. Now, there's our common factor, and in one parenthesis we put this 6x plus 1 times 3x minus 2. And they have it there. Now again, for some reason they're switching these around, but this is still good. This is the way I used to do it. Okay, so a good technique when you're stuck. Now, could you have done this by trial and error? Absolutely. But this is another method called the AC method, or factoring by grouping. In example 11, we're going to go to objective 3, factoring by substitution. So here we see a rather complex trinomial. So what we can do here is where we have this, let's substitute this as an x. And the same factor here as an x. So when we write it, we get this. Now, we do factor that into this. And now that we have factored that, we're going to put what x was originally, a plus 3, back in there. We're going to distribute, get this. We're going to combine like terms here, get this, and then the same thing. X here is a plus 3. Combine the 3 and the 1, get a 4. So this then is our final answer after we simplified it. And what technique did we use? We use the substitution technique, where we take our factor as x and then factor that simplified form and then substitute the value for x back in there and then follow through. And you'll have perhaps some practice on this as well. Now in example 12, they're saying we can also use substitution by saying let y equals x squared. So we're just making this. But theoretically, you can factor this straight away. This is going to be 5x squared, and this is going to be here x squared. So you could do it by substituting, or I would just leave it. Now 42 is a famous one that we factor, and we're going to factor it into a 7 and a 6. Now we want our last term to be negative, so one of these has to be positive and the other combination negative. Well, our middle term is positive, so we're going to make this one a positive, this one a negative. So when we do our outers, we get a positive 35. Our inners, a negative 6, and it adds up then to a positive 29 x squared. And there's our factorization. Now you could have substituted and then replaced the y's here with the x squares, or just do it straightforward here. This was a long lesson, 35 minutes, but hopefully we covered lots of things, and now you're going to get a chance to practice in our mini lecture.